This is creative problem set number 6, problem number 12. A triangle has vertices 0, 0, 1, 1, and 2 and 0. And the line y equals mx divides the triangle into two triangles of equal area. What is the sum of all possible values of m? So first I drew the triangle with these vertices a, b, c respectively. And I drew the line y equals mx through the triangle. And since it doesn't say that y equals mx plus b, we can assume that the b is 0, so it would go through the origin. And this intersection of between b and c, I will label it as point D. Next, I look at the areas of the big triangle and one small triangle. So area of any triangle is 1/2 the base times the height. I looked at the area of triangle ABC, which has a base of 2m and a height of 1. If I draw the altitude here, you will see the height is 1. And this was simplified down to m. Now they say that when the line y equals mx divides this triangle, it equals the two triangles equal each other. So I looked at triangle ADC, which would have an area, half of the area of triangle ABC, which would be m over 2. If we use this formula, we would have 1/2, and then the base would still be 2m, but the height would be, if we used point D, the intersection point of line BC and line y equals mx, has coordinates x, y. It goes over x units and up y units. And this y coordinate of D is going to be the height of triangle ADC. So this would be y. So if we simplify this down, we have my equals m over 2. And this is what we are going to solve for values of m. So since these two lines intersect each other, we can just set the lines equal to each other and find what x equals. So we know that, or we can find the slope of BC, line BC, is the change of y coordinates over change in x coordinates. So we have 0 minus 1 over 2m minus 0. We can simplify that down. And then I use point 2m0. But you can also use 0.11. You will still get the same answer in the end. So now we have the slope and we have our point. So we can go straight to point slope formula and plug in what we know. So this is the equation of line BC, and we're going to make it equal to the equation of y equals mx. So we have mx equals -1 over 2m times quantity of x minus 2m. Now we're going to multiply both sides by 2m minus 1. And I'm going to distribute this -1 into this quantity, so you get -x plus 2m. And we're going to distribute this mx, so you get 2m squared x minus mx. And I'm going to bring this x to this side, so I can factor out an x. So now our x coordinate is 2m over 2m squared minus m plus 1. Now to get the y coordinate, you can plug this x coordinate back up to the equation of line BC, or you can use the equation of y equals mx, which is given in the problem, and just multiply by m. So m times 2m over 2m squared minus m plus 1. So we get 2m squared So now we have our y coordinate, and now we're going to use this equation up here. So we have my equals m over 2, and we're just going to plug in y to here and then solve for m. So we're going to multiply both sides by 2m squared minus m plus 1. And multiply both sides by 2. Now you can either distribute this m into this quadratic, or I just divided both sides by m, so you get 4m squared equals 2m squared minus m plus 1. Then what I did was I subtracted 2m squared, added m, and minus 1 to the left side. So we get 2m squared plus m minus 1 equals 0. Then we just factor. And solve. By setting each of these equal to 0. So we get m equals 1/2 and m equals -1. But the problem asks for the sum of these possible values of m. So I'm going to label these m1 and m2. So m1 plus m2 equals 1/2 plus -1. And our final answer is -1/2.